Hey guys, welcome to your introduction to gas laws. The first thing I want to do is tell you what we are doing today so we all know what's going on. So the plan for today, first thing, is notes on the gas law. This is where we're going to be talking about what gas law is, temperature, what we hold standard with it, and also a little bit about converting between the temperature units. The next thing is a worksheet on converting temperature. I have a video here for you as well that will go more in detail about how to solve each of the problems on the worksheet. So after you're done with this video, you can check that out. And the last thing is starting to research your gas law project. On your classroom page, you should have a link to an outline for your gas law project as well as a video explaining it. So please look at that before starting your project. Now that being said, I like to start off gas laws with this question. How many of you guys have ever been in a car after you ordered pizza and you're driving home and you smell the pizza inside the car? How many of you guys ever thought, like, oh my god, I cannot wait to have this pizza. This pizza just smells like the best pizza in the world, and I really, really want to start eating it right here, right now. Or maybe you had the same feeling if, like, one of your parents are baking something, your siblings are baking something, or you're cooking something, and you're just like, oh my god, this smells so good, and I cannot wait to eat it. Well, I have some good news for you. When you're smelling that food and you're like, oh my god, it smells so delicious, you're actually eating the particles that you're smelling. So you're actually ingesting a little bit of those gas particles coming off the pizza or whatever's baking or whatever's cooking. Now, there's a dark side to gas laws as well. Now, how many of you guys have ever been into a bathroom after your siblings, your parents, or in the public that just smelled completely awful? Well, the dark side of gas laws is that if you're ingesting the pizza when you're smelling it, you're also ingesting some of those gas particles from the bathroom. Yep. So with that being said, I'm going to start off with our gas notes today. So the introduction to gas notes, the first thing we need to care about is when studying gas laws, we investigate how gases behave when they're under pressure in a closed system. Now, this closed system is super important we have because we need to have a constant amount of moles of a substance, therefore it's not open to the atmosphere. Now, being not open to the atmosphere, that's like when you're driving in your car. When the windows are up and everything is closed, like the doors are closed, the windows are closed, that is considered a closed system in this sense because you're not having the air coming in or out. Now, what happens if you open the windows of your car? Can you really smell the pizza very much? No, it starts to go away. You can't smell it as much, and you're having a hard time smelling what that wonderful pizza smell is. So next we need to talk about is the key concept of pressure in the sense of chemistry. I know we talked about pressure in physics a little bit, but we need to talk about pressure in the sense of our chemical means. So the average pressure of the atmosphere at sea level is taken at standard pressures. We either have 760 millimeters of mercury. This was actually used in a lot of old thermometers. 760 torr, 1 atmosphere, or 101.3 kilopascals. These all equal one another. And because they equal one another, you can use the following converting units of pressure from millimeters of mercury to torr to atmosphere or kilopascals, so you can always convert between any of them. The next thing we need to talk about today is what's known as a standard temperature and pressure. In science, we always love standardizing everything. So we talk about pressure and temperature, we need to know a standard of it. So the freezing point of water will always and forever be 0 degrees Celsius or 273 degrees Kelvin. We'll get into that Kelvin scale in a second. Is defined as standard temperature. Combine those with the conditions of pressure we learned about last slide, we can combine them to refer to something as standard temperature and pressure. Now, something you might be asking is, well, what about the room I'm sitting in right now? Is there a standard for that? And yeah, we have a standard for our regular living conditions that when we're not at sea level, that's known as the normal conditions under which we live in, is referred to as a standard ambient temperature and pressure, or SATP, which is defined as 25 degrees Celsius or 100 kilopascals. This is our area that we normally live in, and the temperature and pressure at our level of sea level. Now, absolute zero. Most of you guys probably have heard about absolute zero, but it never was really explained to you. Now, 0 degrees Celsius or 0 degrees Fahrenheit are not considered absolute zeros. In fact, temperatures will be there, these numbers, and be well below those numbers. In the wintertime, we have a lot of these. A lot of times in winter, we have something going below 0 degrees Fahrenheit and 0 degrees Celsius. We've been out in the weather where it was -5 degrees outside during the winter. So we can't call Fahrenheit and Celsius absolute zero because they can go below zero. Now, if we're talking about absolute zero, it's defined as precisely 0 degrees Kelvin on the Kelvin scale. Now, the Kelvin scale is a thermodynamic temperature scale that deals in absolutes. When we're talking about 0 degrees on the Kelvin scale, that means everything is frozen. Nothing in the whole entire universe could be moving or be in any state other than a frozen state. Now, this is going to be the same as negative 273.15 degrees Celsius. Now, the last thing we need to touch on today is converting between the temperatures. Now, converting from degrees Celsius to degrees Kelvin, what you would have to do is take your degrees Celsius and just add 273.15 to it. You'll get your degrees Kelvin. To go from Kelvin to Celsius, if you add it to Celsius, you're just going to subtract from Kelvin. So you take your temperature in degrees Kelvin minus 273.15 to get back to Celsius. To go from Celsius to Fahrenheit, you take your degrees Celsius, multiply it by 9, divide it by 5, and add 32. To go from Fahrenheit to Celsius, take your degrees Fahrenheit minus 32 times 5 divided by 9. If you'd like to see some examples of this, I have a video link for you right here. So please feel free to check it out and to get ready for your worksheet today. So now we are done with our notes on gas laws. So the next thing you need to do for today is complete that worksheet on converting temperatures. You can follow that video I have for you as well. And the last thing is starting to research your idea for the gas law project you want to work on. If you have any questions, please feel free to email me. I'm more than happy to have meetings with you or answer any emails you have. In any case, have a great day and hope to hear from you guys soon. Bye.